Hello, folks. This is chapter 3-1. This is recording number 1. I think it's worth a few minutes of our time to take a look at where we are in the table of contents, because the table of contents gives us an overview. And as we go along, I'll be doing this all the time, kind of giving you a perspective and kind of a roadmap of what we've covered and what we're going to be covering. So chapter 1 was just an overview of what probability statistics is all about. So let's not spend any more time on that. What I wanted to talk to you about is that chapter 2 is the so-called frequency distributions. Now, I need you to make sure you understand this concept. When we talk about frequency, we're talking about how many times something occurred. And we have actually done measurements as an example. So there are several examples in chapter 2. I don't want to reiterate those examples. The key thing I want you to understand is that frequency distributions means how many times did something actually occur. That's the frequency. Distributions is how is it spread out. This is different from what we're going to see in chapter 4, which is probability, and then in chapter 5, probability distributions. The difference is that in a probability distribution, nothing has happened yet. This is your best guess as to what is going to happen. That's what a probability distribution is. A frequency distribution is a description or a distribution of what has occurred, how many times did it occur, that sort of thing. So in a frequency distribution, it's already occurred. In a probability distribution, it has not occurred. It's what we think is likely to occur. It's our best guess as to what is going to occur. So where does chapter 3 fit? Chapter 3 is data description, but it's data description for the frequency distributions. Chapter 3 is telling us what has actually happened already. How do we describe that data, how those occurrences? Now, the reason I'm talking about this is because this is a very, very common area that people get confused. In chapter 3, when we're talking about the data description, we're going to talk about things like measures of central tendency and measures of dispersion, things of that sort, okay? And then later on, when we're talking about probability distributions, we will use the exact same words but it's a different concept because frequency distribution is different from probability distribution. However, even though they're different, they have a lot of similarities. So it's very easy to get them confused. So just for right now, we're going to just talk about data descriptions, talking about frequency distributions. I'm sorry, I may have said that wrong. We're going to talk about a data description, talking about these frequency distributions. This is stuff that has already happened. And then later on, we'll talk about probability distributions. Just keep in mind, we're going to use the same words, but it's going to be a somewhat different concept. Okay, so without further ado, let us get to chapter 3. Okay, so chapter 3, data description. First part is the measures of central tendency. Then we talk about measures of variation, measures of position. And then section 3, 4, I may or may not cover that. We may just skip that. Okay, so central tendency is something you've heard of a million times in your life. You've heard of people talking about what the average is. When we talk about the average of something, we're talking about a measure of central tendency. Measure of variation is a way of describing how the data is spread out. Is it spread out or is it not spread out? And then measures of position is very straightforward in my view. It's what everybody wants to think about their kids. Oh, my kid's in the top 10%, or my kid's in the top 5%. That's what we mean by measure of position. All right, now I am begging you, read these objectives. Okay, make sure you read what the objectives are. Okay, give me 1 second. The reason I want you to read that carefully is because it gives you the motivation for why this chapter is important. And let me just do it really, really quick, but superficially. You need to read this yourself. the objective is to be able to summarize the data. So remember, this is the frequency distribution. So it's things that have already occurred. So you summarize the data, things that you have already observed or measured or what have you. Okay, so you're going to be able to summarize the data, but then you're going to be able to describe the data. Now, the reason this is important is because many times in real life, it's too hard to look at the data itself. There might be millions and millions of data points, and you just cannot possibly get your arms around it. So what you will do is you will summarize the data, and you'll talk about the average of the values, for example. That's the measures of central tendency, the mean, median, mode, and mid-range. Then, in addition to summarizing it, maybe you're going to describe it, and the reason you describe it using this measures of variation, like how spread out is the data. So we'll see examples of that, but this is very common, necessary type of a skill to have. Okay. Okay, folks, so I'm going to let you read this yourself, but the concept is very important, very simple, however, and that is that, you know, what we did in chapter 2 is we organize the data, we put it into a frequency distribution, and there it is. There's the data. There's the information. The next step is right now, is in chapter 3. Now we're going to not organize it, it's already been organized, but we're going to summarize and we're going to describe the information. Okay, so I don't have anything to add to this. I think the book is very well written. Read this over carefully and you'll get the idea of why this is important. Okay. All right, so let's get to the math part that I hope I can help you with. Give me 1 second here. Okay, so the first thing we talk about is measures of central tendency. Now, we're only going to look at a few of these. There are others, and the exercises, they talk about some other types of averages. And if I get a chance, and I'm pretty sure I will, I'll make a video about those different measures. Instead of just looking at the mean, the median, and the mode, there's other ones as well. So-called arithmetic average, the harmonic mean, things of that sort. Okay, so I'll make videos about those if I possibly can. I'm pretty sure I will. I may post that later on, though. It may be, you know, down the road. So I'll try to make an announcement saying that, hey, I've posted this. I think it's important because even though it's not part of this class necessarily, it's important for you to know that they exist, even if you don't have the ability right at this moment to do the calculations. At least you know they exist. So if you read about it in another class, you'll say, okay, yeah, I remember that. I remember talking about that. And you can always, getting the formulas and cranking out the answers is oftentimes the easiest part of this. It's just understanding the concepts behind it that's the hard part. But cranking out the information, I mean, that's why we invented the internet, right? There's a million there's a million sites out there that you can just type in the data and you'll come up with the actual calculations. Okay, so I want to highlight 1 or 2 things here. As you have perhaps noticed, I'm really into making sure that we have the exact language, that the language that we use is clear. Unfortunately, and I have no control over this, we're using this word statistic in a different way right here. So you understand the difference between a sample and a population, okay? A population is what we are concerned about, and I'm going to use my standard example. If we're talking about all of the students in the Riverside Community College District, there's 3 campuses. There's probably in the neighborhood of 70 to 100,000 students, something like that. Many students, tens of thousands of students. That's the entire population. So the population is whatever it is that you're interested in. A sample is a sample. It's a subset of the population. You select a sample and you try your best to draw an inference. An inference is a conclusion, right? So you pull a sample and you draw an inference from the sample about the population. So if I were interested, for example, in the population of Riverside Community College District students, and I wanted to know, well, what do I think the percentage of the population is that has a job? Well, what I might do is I might draw a sample from the population. Now, as we've discussed previously, if the sample is not drawn properly, your conclusions are not going to be correct. So it's very important that you know what you're doing when you draw the sample. But if you draw the sample properly and you draw inferences or draw conclusions about the population. So here's the point I'm trying to make. When we talk about a sample, we're talking about a statistic. A statistic is a characteristic or a measure obtained by using the data values from a sample. So you draw a random sample of 500 students from the tens of thousands of students, and you talk about, let's say, for example, the average of those students, okay, or whatever it is. Like, let's say you want to know what their age is. Let's just take age as an example. Okay, so you want to know what the age is. Well, that's a statistic because it's a measure or it's a characteristic that you obtain, and you're using data values or data points from a sample. On the other hand, a parameter, it might be the exact same thing. It might be the average, okay? But the parameter is a characteristic or measure obtained by using all of the data values from a specific population. Very, very confusing. That's why I'm trying to really stress this. Let's take the average. If I'm talking about the average, hopefully we all know what average is, but we'll learn about it in a minute. If you're taking the average and if it's a sample, it's called a statistic. If you're taking the average and it's from the population, it's the exact same concept, but instead of calling it a statistic, we call it a parameter. Okay. The reason this is important is later on, when we talk about all kinds of things, we're going to be throwing these terms around very often. And if you don't readily, just intuitively understand the difference between a statistic and a parameter, the explanations and the concepts are not going to make any sense. The way I remember it is, I think to myself, if I have a sample starts with S, statistic starts with S. So if I'm dealing with a sample, I'm talking about a statistic. If I'm dealing with a population, that starts with a P, and the word parameter starts with a P. So that's how I remember it. This is a rounding rule. I'm going to let you read that yourself. I couldn't care less about rounding rules, but it is what it is. Those are the rules, okay? All right, so the very first thing we're going to talk about is the mean, okay? There's three common ways of measuring the central tendency, and that's the mean, the median, and the mode. Where does he say that? Well, I guess he doesn't say it ahead of time, but that's what it is. Okay, there's three ones that we use commonly: the mean, the median, and the mode, and we'll see each one of those in turn. Okay, so I'm almost at the end of this video, so I only have 15 minutes on each video, so I think I'll go ahead and stop this one, and then the next video we'll get started on how to calculate the mean, and I'll give you a little foreshadowing here, and that is that there are two different ways of calculating. Oh, there's only one way of calculating the mean. There's going to be whether you're doing it as a sample or whether you're doing it as a population. But then later on, when we get into measures of dispersion, there's two different ways of calculating the variance, and it depends upon whether you're talking about a sample or whether you're talking about a population. For the mean, it's the same way of doing it. So you may, at this point, after we talk about this, you may say, geez, this seems like you made a mountain out of a molehill, making the distinction between sample and population. But you're just going to have to trust me on this. You do need to know the distinction there. Okay, so let me go ahead and end this video.